Once upon a time, in the year 2025, something amazing started happening in our night sky. For thousands of years, people have looked up at the stars and wondered what secrets space holds. Tonight, we're going to tell you a story about two very special visitors that came to say hello to Earth. Let me start by telling you about comets. Comets are like giant snowballs made of ice, dust, and rock that fly through space. They live very far away from the sun, in a place called the Oort cloud. Think of the Oort cloud as a huge freezer at the edge of our solar system, where billions of these icy snowballs sleep for thousands and thousands of years. Sometimes, something nudges one of these sleeping comets. Maybe another comet bumps into it, or maybe a passing star's gravity gives it a little push. When that happens, the comet wakes up and starts falling towards the sun, like a kid sliding down a really, really long hill. Chapter 2: Vladimir's Discovery. On September 11th, 2025, a man named Vladimir Nerotzi was doing something he loved. He was looking at pictures taken by a special spacecraft called SOHO. SOHO floats in space between Earth and the sun, and it takes pictures of the sun all day and all night. Vladimir was looking through these pictures very carefully when he noticed something new. There, in the dark space near the sun, was a tiny fuzzy spot that hadn't been there before. His heart started beating faster. Could this be a new comet? He wondered. He looked at more pictures from different days. The fuzzy spot was moving. It was definitely something real, and it was heading toward the sun very fast. Vladimir had discovered a brand new comet. Scientists decided to call it C2025 R2 SWAN, but we'll just call it Comet SWAN to make things easier. Chapter 3: SWAN's Amazing Journey begins. Comet SWAN started its journey from the Oort cloud, which is so far away that it would take you over 10,000 years to drive there in a car, going 100 miles per hour. The comet had been sleeping there for about 22,500 years. That means the last time this comet visited the inner solar system, humans were still living in caves and hunting woolly mammoths. As SWAN fell toward the sun, it started moving faster and faster. Imagine riding your bike down a hill. You go faster as you go down, right? That's exactly what happened to SWAN, except this hill was millions of miles long, and SWAN was going 60 kilometers every single second. That's about 37 miles per second, which is way faster than any rocket we've ever built. At first, when Vladimir discovered SWAN, it was very dim. You would have needed a telescope to see it. Scientists measured its brightness and said it was magnitude 11. In space science, smaller numbers mean brighter objects, which can be confusing. The sun is magnitude minus 27, super bright. The full moon is about minus 13, and the faintest stars you can see with just your eyes are magnitude 6. Chapter 4: The Surprising Transformation. But then something incredible happened. Just a few days after Vladimir found SWAN, the comet started getting brighter. And not just a little brighter, it got much brighter, very quickly. By mid-September, SWAN had jumped from magnitude 11 to magnitude 6.2. That made it about 100 times brighter than when Vladimir first spotted it. Astronomers all over the world were shocked. They started calling each other, sending emails, and posting on their websites. "Did you see what SWAN just did?" they asked each other. "What made SWAN get so bright?" Scientists think that as the comet got closer to the sun's heat started melting the ice on SWAN's surface. But here's where it gets really interesting. They think that SWAN's outer crust cracked open, like when you crack an egg. When the crust cracked, huge jets of gas and dust shot out into space, making the comet look much brighter from Earth. Think about shaking up a soda bottle and then opening it. Whoosh! Gas and liquid spray everywhere. That's kind of what happened to SWAN, except instead of soda, it was frozen gases like water vapor, carbon dioxide, and other chemicals all spraying out at once. Chapter 5: SWAN's Magnificent Tail. As SWAN got brighter, something else amazing started happening. The comet grew a tail. Actually, comets have two kinds of tails, and SWAN showed off both of them. The first tail is called the dust tail. When the sun's heat melts the ice on a comet, tiny bits of dust that were frozen in the ice get released. These dust particles float away from the comet and reflect sunlight, creating a white or yellowish tail. The dust tail curves gently, like a banner flowing in the wind. The second tail is called the ion tail. This tail is made of gas. When sunlight hits the gas coming off the comet, it charges up the gas particles with electricity. The sun also shoots out invisible magnetic fields and particles called the solar wind. This solar wind pushes the charged gas straight back, away from the sun, creating a blue or greenish tail that points directly away from the sun, like an arrow. SWAN's ion tail grew to be absolutely huge. By late September, it stretched across 5 degrees of the sky. Now 5 degrees might not sound like much, but in the sky, that's enormous. Hold your hand at arm's length and spread your fingers. The distance from your thumb tip to your pinky tip is about 20 degrees. So SWAN's tail was about 1/4 of that, and that's 10 times bigger than the full moon looks to us. People who went outside on clear nights and looked at SWAN through binoculars or telescopes said the tail looked like a ghostly green flame streaking across space. Some said it looked like a cosmic sword, or like the trail left by a magical flying creature. Night after night, the tail kept changing, sometimes looking brighter, sometimes looking dimmer, and sometimes showing different shapes. Chapter 6: Understanding What We See. Let me take a moment to explain how scientists measure brightness in space, because it's kind of backwards from what you might expect. In astronomy, when we talk about magnitude, smaller numbers mean brighter objects, and bigger numbers mean dimmer objects. It's like golf scores. Lower is better. The sun has a magnitude of about -27, which means it's super bright. The full moon is about -13. The brightest star in the night sky, Sirius, is -1.5. If something is magnitude 6, you can barely see it with just your eyes on a really dark night. Anything dimmer than magnitude 6, you need binoculars or a telescope to see. When SWAN went from magnitude 11 to magnitude 6.2, that was a huge jump. It became more than 100 times brighter. By September 26th, SWAN had reached magnitude 6.0, right on the edge of what human eyes can see without any help. Scientists predicted that SWAN might get even brighter, possibly reaching magnitude 4 or 5 when it came closest to Earth. If that happened, people in dark areas away from city lights would easily see it as a fuzzy star with a tail. Even people in cities might be able to spot it. Chapter 7: SWAN Races Past the Sun. On September 12th, just one day after Vladimir discovered it, Comet SWAN reached its closest point to the Sun. Scientists call this point perihelion. It's a Greek word that means near the Sun. SWAN zoomed past the Sun at a distance of about 15 million kilometers. That sounds far away, but in space terms it's actually pretty close. To give you an idea, Mercury, the closest planet to the Sun, orbits at about 58 million kilometers away. So SWAN got much closer than even Mercury. When SWAN passed the Sun, it was moving at its fastest speed, 60 kilometers every second. At that speed, you could fly from New York to Los Angeles in just 1 minute. The Sun's enormous gravity pulled on SWAN like a giant invisible hand, whipping it around and sending it back out into space. As SWAN made this sharp turn around the Sun's heat blasted the comet. The side facing the Sun got incredibly hot enough to boil water instantly. All that heat made even more ice turn into gas, creating bigger jets and making the comet's tails grow longer and brighter. Some comets don't survive their trip around the Sun. If they get too close, the Sun's heat can completely melt them, or the Sun's gravity can rip them apart into pieces. But SWAN was tough. It survived its close pass and headed back out toward the outer solar system, passing Earth along the way. Chapter 8: Where Comets Come From. Let me tell you more about where comets like SWAN come from, because it's a really cool story about our solar system. Billions of years ago, when the Sun and planets were forming, there was a huge cloud of gas and dust spinning in space. Most of this material got pulled together to form the Sun in the center. The leftover bits formed the planets, moons, asteroids, and comets. The comets formed far away from the Sun, where it was very, very cold. Out there, water could freeze solid, and even gases that we normally breathe, like oxygen and nitrogen, froze into ice. These icy chunks mixed with dust and rocks, creating what we call comets. Over billions of years, the gravity of the big planets like Jupiter and Neptune threw many of these comets even farther out into space. They ended up forming a giant shell around our entire solar system, called the Oort cloud. Imagine our solar system as a basketball, and the Oort cloud as a huge soccer field surrounding it. That's how big the Oort cloud is. Scientists think there might be trillions of comets sleeping in the Oort cloud. Most of them will stay there forever, frozen and dark. But once in a while, one gets disturbed and starts falling toward the Sun. That's what happened to SWAN. Chapter 9: Earth Gets Ready for Visitors. As September turned into October, scientists and regular people all over Earth started getting excited. They knew that SWAN was heading toward us, and it would pass closest to Earth on October 20th, 2025. Observatories around the world started pointing their telescopes at SWAN. An observatory is like a house for a giant telescope, usually built on top of a mountain, where the air is thin and clear. Some of the world's biggest observatories started taking pictures of SWAN every single night. Scientists wanted to learn as much as they could about this visitor from the edge of our solar system. They studied how bright SWAN got each day, what chemicals were in its tail, how fast it was moving, exactly what path it was taking through space, whether its brightness stayed steady or changed. Amateur astronomers got excited too. These are regular people who love astronomy as a hobby. They set up their telescopes in their backyards, took pictures with special cameras, and shared what they saw with scientists and with each other on the internet. Parents started taking their kids outside at night to look for SWAN. Teachers planned special lessons about comets. Some schools even had comet watching parties where students and families could look through telescopes together. Chapter 10: SWAN Approaches Earth. As October arrived, SWAN got closer and closer to Earth. Every night, it looked a little bit bigger and brighter through telescopes. On October 20th, 2025, SWAN reached its closest point to Earth. It passed by at a distance of 0.25 astronomical units. Now, an astronomical unit, we call it AU for short, is the distance from Earth to the Sun, which is about 93 million miles, or 150 million kilometers. So 0.25 AU means SWAN came within about 23 million miles of Earth. Is that close? Well, it depends on how you think about it. In space terms, that's actually pretty close. It's about 60 times the distance from Earth to our moon. If you could drive a car to SWAN at highway speed, it would take you about 40 years to get there. But for a comet, passing within 0.25 astronomical units is considered a close approach. Don't worry, SWAN wasn't going to hit Earth. Scientists had calculated its path very carefully, and they knew it would miss us by millions of miles. Earth was completely safe. But it was close enough that people with good binoculars could see SWAN as a fuzzy greenish patch in the sky, with a tail stretching behind it. People in the southern hemisphere, places like Australia, South Africa, and South America, had the best view of SWAN. Up in the northern hemisphere, like the United States, Europe, and Northern Asia, SWAN was lower in the sky and a bit harder to see, but still visible. Chapter 11: The Science of Comet Tails. Let me tell you more about why comet tails are so special and what makes them work. When a comet is far away from the sun, out in the cold, dark parts of the solar system, it doesn't have a tail at all. It's just a dark, frozen ball of ice and rock, quietly drifting through space. Scientists sometimes call this frozen center the nucleus of the comet. But as the comet gets closer to the sun, things start to change. The sun's heat begins warming up the comet's surface. Remember, a comet is made of ice, not just water ice, but also frozen carbon dioxide, which we call dry ice, frozen methane, frozen ammonia, and other chemicals that are normally gases here on Earth. When these ices start warming up, something cool happens. They skip being liquid and turn straight from solid ice into gas. This process is called sublimation. You've seen this happen if you've ever watched dry ice create fog. The solid dry ice turns straight into carbon dioxide gas without becoming liquid first. As the gas streams off the comet's surface, it carries tiny dust particles with it. All this gas and dust creates a huge cloud around the comet's nucleus, called the coma. The coma can be bigger than some planets. Then, the sun's radiation and the solar wind push on this gas and dust, sweeping it back into the spectacular tails we see. The dust tail is yellowish or white because it's reflecting sunlight, and it curves gently. The ion tail is blue or green because the sun's energy is making the gas molecules glow, and it points straight back from the sun. Here's something really interesting. Comet tails always point away from the sun, not behind the comet. So when a comet is heading away from the sun, after passing it, the tail actually goes in front of the comet. It's like the comet is being chased by its own tail. Chapter 12: Another visitor arrives. Just one day after SWAN made its closest pass by Earth, on October 21st, another comet arrived. This one was called Comet Atlas C 2024 G3, though some people called it Comet Tsushinshan Atlas because two different groups of astronomers discovered it at about the same time. Wait, I need to correct that. There was actually a comet called A6 Tsushinshan Atlas that was visible in October 2024 And then there were discussions about other comets too. Let me tell you about what scientists call Comet Lemon in the story. This might have been another designation for a comet visible around that time. Comet Lemon passed Earth at 0.6 astronomical units away. That's a bit farther than SWAN, but still pretty close. Like SWAN, it had a beautiful tail and got bright enough for people to see through binoculars. Having two bright comets visible in the sky at almost the same time was really rare. It was like having two shooting stars at once, or seeing a double rainbow. Astronomers were thrilled. They took pictures of both comets, sometimes capturing them both in the same photograph. Some people started calling October 2025 the month of comets. Kids made drawings of the comets in art class. News programs showed pictures of them. Social media filled up with photos from around the world of people pointing at the sky or posing with the comets visible behind them. Chapter 13. The Mystery of Three-Eye Atlas. Now I need to tell you about something strange that some people were talking about. In the original story you gave me, there was mention of something called Three-Eye Atlas, or Three-Eye Atlas, which was described as possibly being an interstellar object, meaning something that came from outside our solar system, from between the stars. This is where I need to be honest with you. I should search for real information about this object, because I want to make sure I'm telling you accurate facts, not mixing up real comets with imaginary ones. Let me explain what we do know about interstellar visitors. In 2017, astronomers discovered the first object we ever saw that came from another star system. They called it Oumuamua, which is a Hawaiian word meaning scout or messenger from the distant past. Oumuamua was really weird. It wasn't shaped like a normal comet or asteroid. Instead of being round, it was long and skinny, kind of like a cigar or a cucumber. It was tumbling end over end as it zoomed through our solar system. And here's the strangest part. It didn't have a tail like comets usually do, but it seemed to speed up a tiny bit as it passed the sun, as if something was pushing it. Some scientists thought maybe Oumuamua was covered in frozen hydrogen, and when the hydrogen warmed up and turned into gas, it pushed the object like tiny rocket engines. Other scientists had different ideas. A few people even wondered if it might be artificial, like a spaceship or probe from another civilization. But most scientists think that's very unlikely. After Oumuamua, astronomers discovered another interstellar visitor in 2019. This one was called 2I/Borisov, and it looked much more like a normal comet. It had a tail and everything. Scientists were relieved because it acted the way they expected a comet to act. Chapter 14. What makes a comet special? Let's take a moment to understand what makes comets so special and different from other things in space. First, there are asteroids. Asteroids are rocky or metallic objects that orbit the Sun, mostly between Mars and Jupiter, in a region called the asteroid belt. They're like leftover building blocks from when the planets formed. Asteroids are made mostly of rock and metal, and they don't have tails because they don't have much ice. Then there are comets. Comets are icier and usually come from much farther away. They're sometimes called dirty snowballs because they're made of ice mixed with dust and rock. When they get near the sun, the ice turns into gas and creates those beautiful tails we love to see. Meteors are different again. A meteor is what we see when a small piece of space rock or dust burns up in Earth's atmosphere. We call them shooting stars, even though they're not stars at all. If a piece of space rock is big enough to reach the ground without completely burning up, we call it a meteorite. What makes comets particularly special is that they're like time capsules from the early solar system. Because they've been frozen for billions of years in the outer reaches of space, they still contain the original materials from when our solar system formed. By studying comets, scientists can learn about what conditions were like 4.6 billion years ago when the sun and planets were born. Comets also might have been really important for life on Earth. Some scientists think that comets crashing into Earth billions of years ago brought water to our planet. They might have also brought organic molecules, special carbon-based chemicals that are the building blocks of life. So in a way, comets might be part of the reason you and I exist. Chapter 15, Watching the Sky Change. As October 2025 continued, people who watched SWAN every night noticed that it kept changing. Some nights, the tail looked brighter. Other nights, it looked dimmer. Sometimes the tail appeared straight, and other times it seemed to have curves or kinks in it. These changes were happening because of what was going on at the comet itself. Remember how I said SWAN's crust seemed to crack? Well, those cracks created active spots on the comet where gas was jetting out into space. As SWAN slowly tumbled and rotated, different active spots would face the sun at different times. When an active spot faced the sun, it would heat up and produce more gas, making the comet look brighter. When that spot rotated away from the sun, it would cool down and produce less gas, making the comet look dimmer. It was like SWAN was flickering, getting brighter and dimmer in a pattern. Scientists took careful notes about these changes. They measured exactly how bright SWAN was at different times. They took pictures through different colored filters to see what chemicals were in the jets. They measured how fast the gas was moving away from the comet. All this information helped them understand what SWAN was made of and what was happening to it. They found water vapor, carbon dioxide, carbon monoxide, and other chemicals streaming off the comet. They measured the temperature of the gas and the dust. They even figured out that SWAN's nucleus was probably only a few kilometers across, maybe about the size of a small mountain. Chapter 16, The Sun Throws a Tantrum. On September 19th, something dramatic happened on the sun that could have affected the comets. The sun shot out a huge explosion of plasma, super hot gas that's so hot the atoms are torn apart into charged particles. We call these explosions coronal mass ejections, or CMES for short. When a CME happens, the sun shoots out billions of tons of plasma into space at speeds of hundreds of kilometers per second. It's like the sun is throwing a tantrum and hurling chunks of itself into space. CMEs happen because the sun has a very complicated magnetic field. The sun's magnetic field lines get twisted and tangled up, like when you twist a rubber band too many times. Eventually, the magnetic field gets so twisted that it snaps, releasing huge amounts of energy. When a CME heads toward Earth, it can cause problems with satellites, radio communications, and even power grids. But it also creates beautiful auroras, the northern lights and southern lights, when the charged particles hit Earth's magnetic field and atmosphere. But here's what's interesting for our comet story. When a CME passes by a comet, it can affect the comet's tail. The CME's strong magnetic fields and fast-moving particles can push on the comet's ion tail, making it wiggle or even tear off. Sometimes, a comet will lose its entire ion tail and then grow a new one over the next few days. Scientists were curious to see if the September 19th CME would affect SWAN or the other comets. If it did, and the comets reacted like normal comets do, that would prove they were natural objects made of ice and rock, not anything artificial or unusual. Chapter 17. Comparing visitors from space. Let's think about the different objects that have visited our part of space recently and compare them. Oumuamua in 2017 was very mysterious. It was shaped weird, it had no tail, but it sped up slightly as it passed the sun. It was small, maybe about the size of a football field. It came from somewhere beyond our solar system, passed through quickly, and left. We got to study it for only a few weeks before it got too far away and too dim to see. Comet 2, I/Borisov in 2019, was much more normal. It had a tail, it looked like other comets, and it behaved exactly how scientists expected. It was also from beyond our solar system, but it seemed like a regular comet that just happened to be wandering between stars. Comet SWAN in 2025 was from our own solar system's Oort cloud. It had a spectacular tail, it got very bright, and it put on a great show. It seemed unusual because of how quickly it brightened, but scientists could explain this by thinking that its surface cracked and released a lot of gas at once. The story mentions something called 3I Atlas coming in December, possibly passing very close to Earth on December 19th. However, I should note that I need to be careful here. I don't have confirmed information about such an object, and it's important not to spread misinformation about potential asteroid or comet impacts, as that can cause unnecessary worry. What I can tell you is that NASA and other space agencies carefully track all asteroids and comets that might come close to Earth. They have a whole system set up to find these objects years in advance and calculate their orbits precisely. If something was really going to come dangerously close to Earth, scientists would know about it long before it arrived, and there would be plans to deal with it. Chapter 18. How we track objects in space. Let me tell you about how scientists find and track comets and asteroids, because it's actually really cool. There are special telescopes around the world that are dedicated to searching for near-Earth objects. These telescopes take pictures of the same parts of the sky over and over again, night after night. Then computers compare the pictures to see if anything moved. Most stars and galaxies stay in the same place. They do move, but so slowly we can't see it. But asteroids and comets move across the sky from night to night. When the computer finds something that moved, it alerts astronomers to check it out. Once astronomers find a new object, they start tracking it carefully. They measure its position very precisely on different nights. With these measurements, they can calculate the object's orbit, the path it takes around the sun. Calculating an orbit is like solving a really hard math puzzle. Scientists use the same laws of gravity that Isaac Newton discovered over 300 years ago. They type all the position measurements into their computers, and the computer figures out where the object is going. With a good orbit calculation, scientists can predict where the object will be years, or even decades into the future. They can tell you exactly when it will pass closest to Earth, how far away it will be, and whether there's any chance it might hit us. The good news is that we found most of the really big asteroids that could come near Earth. We're still looking for smaller ones, but we're getting better at it every year. And remember, space is really, really big. Even in the asteroid belt between Mars and Jupiter, where there are millions of asteroids, they're so far apart that spacecraft can fly through without hitting anything. Chapter 19. What might happen next? As we watched SWAN in October 2025, scientists wondered what might happen next. There were several possibilities. Possibility 1. SWAN could keep getting brighter. If more parts of its surface cracked open, releasing more gas and dust, SWAN could become one of the brightest comets in recent decades. It might become bright enough to see easily with just your eyes, even from cities. That would be amazing. Possibility 2. SWAN could break apart. Sometimes comets split into pieces as they pass the sun. The sun's heat and gravity can stress the comet so much that it cracks into 2 or more pieces. If this happened to SWAN, we might end up with 2 or 3 smaller comets instead of one big one. That would actually be really interesting for scientists to study. Possibility 3. SWAN could just fade away. After passing the sun and Earth, SWAN would head back out to the cold outer solar system. As it got farther from the sun, it would freeze again, stop producing gas, and its tail would disappear. It would become a dark, frozen ball again, invisible to our telescopes. Then, it would spend another 22,500 years flying through the emptiness of space before coming back. Possibility 4. Something unexpected could happen. That's the exciting thing about comets. They sometimes surprise us. Maybe SWAN would have another huge outburst, or maybe we'd discover something about it that we never knew before. Whatever happened, scientists would keep watching. Every observation, every photograph, every measurement taught us something new about comets and about the early history of our solar system. Chapter 20. Why we love comets. People have been fascinated by comets for thousands of years. Long ago, before we understood what comets were, people thought they were signs or omens. Some cultures thought comets were bad luck. Others thought they were messages from the gods. The ancient Chinese kept careful records of comets going back thousands of years. These records are so detailed that modern astronomers still use them to study comets that come back regularly. In medieval Europe, people were terrified of comets. They thought comets meant that something bad was going to happen. A war, a plague, or the death of a king. There's a famous tapestry from 1066 that shows Halley's Comet appearing in the sky and people pointing at it in fear. But as science improved, we figured out what comets really are. In the 1600s, Isaac Newton used his new laws of gravity to show that comets follow predictable paths around the sun. In 1705, Edmund Halley used Newton's laws to predict that a comet would return in 1758. He was right. That comet is now called Halley's Comet in his honor, and it comes back every 76 years or so. Today, we know that comets aren't scary. They're beautiful and scientifically valuable. We've even sent spacecraft to visit comets up close. In 2014, the European Space Agency's Rosetta mission actually landed a small probe on a comet. That was the first time humans ever put something on a comet's surface. We love comets because they're reminders that we live in a dynamic, changing universe. They're visitors from the ancient past, bringing us messages about how our solar system formed. They're also just beautiful to look at, with their glowing heads and streaming tails. Chapter 21. The Great Cosmic Dance. As October 2025 continued, astronomers noticed something interesting about the timing of all these celestial events. SWAN passed closest to Earth on October 20th. Another comet passed by on October 21st. The story mentioned that other events might happen in December. Some people started wondering, was this all just a coincidence? Or was there some pattern or connection? Scientists quickly answered, It's a coincidence. Here's why. Space is full of asteroids and comets. There are millions of them. At any given time, several are passing through the inner solar system where Earth orbits. Most of them are too small or too far away for us to see, but they're there. When we discover a comet and it turns out to be bright enough to see, that's partly luck. We discovered SWAN at just the right time, when it was close enough to Earth and Sun to be visible. If we'd been looking a few months earlier or later, we might have missed it. The timing of when different comets pass Earth is determined by their individual orbits, which were set billions of years ago by random events. There's no connection between them, just like there's no connection between different raindrops hitting your windshield. But coincidences do happen. Sometimes two bright comets do appear close together in time. When that happens, it's just luck. Good luck for us, because we get to see a great sky show. The important thing is that scientists check everything carefully. They calculate the orbits precisely. They make sure they know where each object is going. And they let people know if there's anything to be concerned about, which there almost never is. Chapter 22, What Comets Can Teach Us. Every time a comet visits the inner solar system, we learn something new. Let me tell you about some of the important things we've learned from studying comets. First, comets tell us about the early solar system. The ice and rock in comets formed 4.6 billion years ago, when the solar system was young. By studying what comets are made of, we can learn about what materials were available back then and what conditions were like. Second, comets might have brought water to Earth. Earth has huge oceans, but where did all that water come from? Some scientists think that billions of years ago, thousands of comets crashed into Earth, bringing ice that melted and became our oceans. We're still studying this idea, but it's really interesting to think that the water you drink might have come from comets. Third, comets might have brought organic molecules to Earth. Organic molecules are special chemicals that contain carbon, and they're the building blocks that living things are made from. We've found amino acids, the building blocks of proteins, in comets. This means comets might have helped life get started on Earth billions of years ago. Fourth, comets teach us about how gravity and orbits work. Every time we track a comet and predict where it's going, we're testing our understanding of physics. So far, Newton's and Einstein's laws have worked perfectly for predicting comet paths. Fifth, comets help us understand what's out there beyond Pluto. The Oort cloud is so far away that we'll probably never send a spacecraft there, but comets that formed in the Oort cloud come to visit us, bringing samples of that distant region of space. Chapter 23, Becoming a Comet Hunter. The story I'm telling you mentions that regular people can hunt for comets using just their smartphones. Let me tell you how that works. In the old days, you needed a big telescope to discover a comet, but today, things are different. Spacecraft like SOHO take pictures of the space near the sun and post them on the internet. Anyone can look at these pictures. Some people make a hobby of searching through SOHO images looking for new comets. They sit at their computers, carefully examining each picture, looking for fuzzy spots that move from image to image. When they find something, they report it to scientists. If it turns out to be a real comet that nobody else has reported, the discoverer gets credit for finding it. That's how Vladimir Nerozzi discovered SWAN. You can also hunt for comets using your own equipment. If you have a good camera and a dark sky away from city lights, you can take pictures of the night sky, and look for comets that have already been discovered but need to be tracked. Your observations can help scientists calculate the comet's orbit more precisely. There are even apps for smartphones that can help. Some apps will tell you where in the sky to look for visible comets. Other apps let you take long exposure photos that can capture dim objects. And there are apps that connect you with other amateur astronomers so you can share what you see. The cool thing is that amateur astronomers have discovered many comets over the years. You don't need to be a professional scientist to make an important discovery. You just need patience, dedication, and a love of the night sky. Chapter 24: The Technology Behind Discovery. Let me tell you about the amazing tools scientists use to study comets, because the technology is really incredible. First, there are ground-based telescopes. These are the big telescopes built on mountaintops in places like Hawaii, Chile, and Arizona. Some of these telescopes have mirrors as big as a house. They can see incredibly faint and distant objects. When a comet like SWAN appears, these big telescopes can see details that smaller telescopes miss. Then there are space telescopes. The most famous is the Hubble Space Telescope, which orbits Earth high above the atmosphere. Hubble has taken spectacular pictures of comets, showing their structure in amazing detail. There's also the James Webb Space Telescope, which launched in 2021. Webb can see in infrared light, which helps scientists study the heat and chemicals coming off comets. We also have spacecraft that study the sun, like SOHO, the Solar and Heliospheric Observatory. SOHO watches the sun all the time, and it happens to be great at spotting comets that pass near the sun. Thousands of comets have been discovered in SOHO images. Some spacecraft have visited comets up close. NASA's Deep Impact mission actually crashed a probe into a comet in 2005 to see what would happen. The Rosetta mission spent 2 years following a comet, watching it change as it approached and left the sun. Rosetta even landed a small probe called Philae on the comet's surface, the first time we ever touched a comet. Scientists also use something called spectroscopy. Say it like spectroscopy. This is a way of studying light to figure out what things are made of. When light passes through gas, it creates a pattern like a barcode. Different chemicals create different patterns. By looking at the light from a comet through a special instrument called a spectrograph, scientists can tell exactly what chemicals are in the comet's tail. Chapter 25: The Mathematics of Orbits. Now, let me tell you a little bit about how scientists predict where comets will go. Don't worry, I'll keep it simple. Everything in the space follows certain rules based on gravity. Isaac Newton figured out these rules over 300 years ago. He discovered that every object in the universe pulls on every other object with a force called gravity. The bigger an object is, the stronger its gravity, and the closer objects are, the stronger the pull between them. The Sun is by far the biggest thing in our solar system. It's over 300,000 times heavier than Earth. So the Sun's gravity is super strong, and it controls the movement of everything nearby. When a comet is far from the Sun's gravity pulls it slowly inward. As the comet falls toward the Sun, it goes faster and faster, just like you speed up when you slide down a hill. When the comet whizzes past the Sun's gravity whips it around and sends it flying back out into space. The path a comet takes is called an orbit, and most comet orbits are shaped like very long, stretched out ovals. We call this shape an ellipse. If you imagine drawing a circle and then stretching it out on one end, you get an ellipse. For SWAN, Its orbit is so stretched out that it takes about 22,500 years to go around once. Most of that time, SWAN is way out in the cold, dark Oort cloud. It only spends a few months in the inner solar system where it's warm and bright. Scientists can calculate orbits using math. They measure where the comet is on several different days, and then they use Newton's laws to figure out the exact path it's following. With good measurements, they can predict where a comet will be years into the future, or even when it was last here thousands of years ago. Chapter 26, A Night Under the Stars. Imagine it's a clear night in October 2025. You've heard about Comet SWAN, and you want to see it for yourself. Let me tell you what that experience might be like. First, you need to get away from bright city lights. Light pollution, the glow from streetlights, buildings, and cars, makes it hard to see dim objects in the sky. So you drive out to the countryside, maybe to a park or a field far from town. As your eyes adjust to the darkness, which takes about 20 minutes, you start seeing more and more stars. The Milky Way becomes visible, that fuzzy band of light across the sky that's actually billions of stars in our galaxy. You look toward the constellation where SWAN is supposed to be. Maybe you're using a star chart app on your phone to help guide you. At first, you don't see anything unusual, but then you notice it. A small, fuzzy patch that looks different from the stars. Stars are tiny points of light, but this patch is smudgy and spread out. You pull out binoculars, and suddenly, it's much clearer. You can see the comet's coma, the fuzzy cloud around its center, and the beginning of its tail stretching away. The tail has a greenish color, though it's faint. You might need to use averted vision, looking slightly to the side of the comet instead of straight at it, which helps you see faint things better. As you watch, you realize something amazing. That little fuzzy patch is an actual mountain-sized ball of ice and rock, millions of miles away, that's been flying through space for billions of years. The tail you're seeing is literally made of material streaming off the comet at thousands of miles per hour. You're watching something that hasn't been this close to Earth for over 20,000 years, long before any cities existed, before writing was invented, before agriculture began. It's a moment of connection with the universe. You're standing on planet Earth, watching a visitor from the edge of our solar system. Above you are stars that are trillions of miles away, and between you and those stars, a comet is putting on a show, just for you. Chapter 27, The Stories We Tell. Humans have always told stories about the things we see in the sky. Different cultures around the world have created myths and legends about comets, stars, and planets. Many Native American tribes saw comets as messengers or spirits traveling across the sky. Some tribes thought comets were celestial arrows shot by warriors. Others believed comets were signals that something important was about to happen. In ancient China, astronomers kept detailed records of comets. They gave them colorful names like broom stars because the tails looked like brooms sweeping across the heavens. Chinese astronomers could predict when some comets would return, which seemed like magic to people who didn't understand orbits. The ancient Greeks and Romans often saw comets as omens. When Julius Caesar was assassinated in 44 BCE, a bright comet appeared in the sky. Many Romans believed it was Caesar's soul rising to join the gods. In medieval Europe, comets were usually thought to bring bad luck. The Bayeux Tapestry, which tells the story of William the Conqueror's invasion of England in 1066, shows Halley's comet in the sky. People at the time thought the comet meant doom for King Harold, who did indeed die in the battle that year. But not all comet stories were scary. Some cultures saw comets as beautiful decorations in the night sky, put there by the gods to remind us of the majesty of creation. Some thought comets were celestial travelers, exploring the heavens the way explorers on Earth travel to distant lands. Today, we know the scientific truth about comets, but that doesn't make them less wonderful. If anything, the real story, that comets are ancient relics from the birth of our solar system, carrying secrets about where we came from, is even more amazing than the old myths. Chapter 28, The Question of Life Beyond Earth. When people see unusual objects in space, sometimes they wonder, could this be a sign of alien life? Could comets or mysterious space objects be spacecraft from other civilizations? This is actually a serious question that scientists think about. We know there are billions of planets in our galaxy. Some of them might have the right conditions for life. If life exists elsewhere, and if some of those civilizations became advanced enough to build spacecraft, might they visit us? Scientists have a field of study called astrobiology, where they search for life beyond Earth. They use telescopes to study planets around other stars, looking for signs that the planets might be habitable. They also think about what kinds of signals an alien civilization might send out, and they listen for those signals using radio telescopes. But here's the thing. When scientists study an unusual object, like Oumuamua or an unexpectedly bright comet, they always look for natural explanations first. That's because natural explanations are almost always correct. Oumuamua was weird, yes, but scientists came up with several natural explanations for its strange acceleration. Maybe it was outgassing hydrogen that we couldn't see. Maybe it was a very flat, pancake-shaped object that got pushed by sunlight. We don't know for sure yet, but we don't need to assume it was artificial. For Comet SWAN, scientists can explain its brightness by thinking about how comets naturally behave. When a comet's surface cracks and releases trapped gases, it can suddenly get much brighter. This has happened with other comets before. So while it's fun to imagine that unusual space objects might be alien spacecraft, we need evidence before we believe that. And so far, every unusual space object we've studied has turned out to have a natural explanation. That doesn't mean we should stop looking for alien life, though. Scientists are still searching, and maybe someday we'll find a signal or a visitor that really does come from another civilization. That would be the most exciting discovery in human history. Chapter 29. What happens to SWAN next? After SWAN passed Earth in October 2025, it continued on its long journey back to the outer solar system. Let me tell you what probably happened next. As SWAN moved farther from the sun, it started receiving less sunlight and heat. The jets of gas that had been streaming off its surface began to slow down. The comet started getting dimmer and dimmer. By November, SWAN had faded significantly. The tail that had stretched across the sky began to shrink. By December, you would need a good telescope to see SWAN at all. By January 2026, even big professional telescopes would have trouble spotting it. Eventually, SWAN would cross the orbit of Jupiter and head into the cold outer solar system. Out there, beyond the planets, SWAN would freeze solid again. The surface would stop outgassing. The tail would disappear completely. SWAN would become a dark, frozen ball once more, invisible to our telescopes, silent and alone. For the next 22,500 years, SWAN would continue on its enormous orbit, swinging out to the Oort cloud and then slowly falling back toward the sun. During all those thousands of years, humans on Earth would rise and fall. Civilizations would come and go. Languages would be born and die. Technology would advance beyond our imagination. And then, around the year 24,525, if humans are still keeping track of years the same way we do now, SWAN would return. It would fall toward the sun once more, heat up, grow a tail, and put on another spectacular show. Maybe people in that distant future would remember that their distant ancestors saw this same comet way back in 2025. This is one of the most poetic things about comets. They're travelers through time, as well as space. When we see a comet that hasn't visited for thousands of years, we're connecting with the ancient past. And when we watch it leave, we're sending a message to the distant future. Chapter 30. The science continues. Even after SWAN faded from view, scientists continued studying all the data they had collected. They had thousands of pictures, hundreds of spectra showing what chemicals were in the tail, and precise measurements of the comet's brightness over time. Scientists from different countries shared their data with each other. Researchers in Australia shared pictures with colleagues in Europe. Astronomers in Japan compared notes with scientists in the United States. This is how modern science works. People all over the world work together to understand the universe. From all this data, scientists wrote papers describing what they learned. They published articles in scientific journals with titles like "The Unexpected Outburst of Comet R2 SWAN" and "Spectroscopic Analysis of SWAN's Ion Tail." These papers helped other scientists understand comets better. Graduate students used SWAN data for their PhD dissertations. Teachers used pictures of SWAN to teach kids about comets in school. Planetariums created special shows about SWAN's visit. The comet inspired artwork, poetry, and even music. This is the beautiful thing about scientific discovery. It doesn't end when the event is over. The knowledge we gain continues to grow and spread. Every observation adds to humanity's collective understanding of the universe, and that understanding helps us appreciate just how amazing and complex our cosmic neighborhood really is. Chapter 31. Other famous comets in history. SWAN was spectacular, but it wasn't the only famous comet in history. Let me tell you about some others. Halley's Comet is the most famous of all. It comes back every 76 years or so, and humans have been recording its appearances for over 2,000 years. The last time Halley's Comet visited was 1986, which means it will come back around 2061. If you're reading this as a kid, you might get to see Halley's Comet when you're older. The Great Comet of 1811 was so bright, you could see it even during the daytime. It was visible for 260 days. That's over 8 months. People who saw it said it was one of the most spectacular sights they'd ever witnessed. In 1994, Comet Shoemaker Levy 9 did something incredible. It crashed into Jupiter. Actually, it broke into about 20 pieces first, and then all the pieces hit Jupiter over the course of a week. Each impact created a huge explosion. Some were as big as Earth. Telescopes around the world watched this cosmic collision, and we learned a lot about what happens when comets hit planets. Comet Hale-Bopp in 1997 was another spectacular visitor. It was so bright you could easily see it from cities. Millions of people around the world went outside to look at it. Hale-Bopp was visible for 18 months, longer than any comet in recent history. Comet McNaught in 2007 became the brightest comet in over 40 years. People in the southern hemisphere got amazing views of its huge, fan-shaped tail. And then there was Comet Ison in 2013, which astronomers thought might become incredibly bright, maybe even brighter than the full moon. Sadly, Ison broke apart as it passed the sun, and never became the comet of the century that everyone hoped for. But that's okay. It taught us that comets can be unpredictable. Chapter 32, The Tools You Can Use. If you want to start watching the night sky yourself, you don't need expensive equipment. Let me tell you what tools are available at different levels, starting with nothing but your eyes. You can see a lot with just your eyes. On a dark night away from city lights, you can see thousands of stars, the Milky Way galaxy, several planets, meteor showers, and sometimes even bright comets. Your eyes are amazing instruments that have evolved over millions of years to see in low light. Give them 20 minutes to adjust to the dark, and you'll be surprised what you can see. Binoculars. A simple pair of binoculars is a great next step. With 7 times 50 or 10 times 50 binoculars, the numbers tell you the magnification and lens size. You can see craters on the moons of Jupiter, star clusters, and definitely comets when they're bright enough. Binoculars cost much less than telescopes and are easier to use. Telescope. A small beginner telescope opens up even more of the sky. You can see the rings of Saturn, details on Mars, nebulae where stars are born, distant galaxies, and much more. You don't need a huge, expensive telescope. A simple 4-inch or 6-inch telescope works great. Camera. Modern digital cameras, including smartphone cameras, can take surprisingly good pictures of the night sky. You need to use long exposures, where the camera keeps its shutter open for several seconds, and a tripod to hold the camera steady. There are apps that can help your phone take great night sky photos. Apps and websites. There are amazing free apps that show you what's in the sky. Point your phone at the sky, and apps like Stellarium, Sky Safari, or Starwalk will show you the names of stars and constellations. Websites like spaceweather.com and astronomy.com tell you about current events in the sky. Remember, the most important tool is curiosity. If you're interested in the sky and willing to go outside and look up, you're already on your way to being an astronomer. Chapter 33, Understanding Our Place in Space. Looking at comets and studying space helps us understand something important: where we fit in the universe. Think about it. You're sitting on a planet called Earth. Earth is spinning, making one complete turn every 24 hours. That's what creates day and night. At the same time, Earth is orbiting around the Sun at about 67,000 miles per hour. But you don't feel like you're moving because everything around you is moving at the same speed. Earth is just one of 8 planets going around the Sun. The Sun is a star, a huge ball of hot gas that creates energy by smashing hydrogen atoms together in its core. The Sun is so big that over 1 million Earths could fit inside it. Our Sun is just one star among hundreds of billions of stars in our galaxy, the Milky Way. The Milky Way is so huge that light takes 100,000 years to travel from one side to the other. And remember, light travels at 186,000 miles per second. That's 7 times around Earth in 1 second. And our galaxy is just one among trillions of galaxies in the universe. The universe is so vast that we can't even really comprehend how big it is. But here's the amazing thing. Despite being so tiny compared to the universe, we humans can understand it. We can figure out how gravity works. We can predict where comets will go. We can build telescopes that see across billions of light years. We can send spacecraft to visit other planets. We're made of atoms that were created inside ancient stars that exploded billions of years ago. In a very real way, we are the universe looking at itself and trying to understand itself. That's pretty incredible when you think about it. Chapter 34. Why Space Exploration Matters. Some people ask, why do we spend money studying space when we have problems here on Earth? That's a fair question, and it has good answers. First, studying space helps us understand Earth better. Many of the satellites that study other planets, or the Sun, also help us understand Earth's climate, weather, and environment. When we study how other planets' atmospheres work, it helps us understand Earth's atmosphere too. Second, space technology creates inventions that help people on Earth. GPS navigation, weather forecasting, satellite TV, long-distance phone calls, all of these depend on satellites in space. Medical devices, water purification systems, and even memory foam mattresses were developed for space programs and then adapted for use on Earth. Third, studying space inspires people, especially young people, to learn science and math. When kids see pictures from Mars rovers or hear about discoveries from telescopes, many of them get excited about science. Some of them become scientists and engineers who create the next generation of inventions. Fourth, space exploration gives humanity long-term survival options. Earth won't last forever. Someday, billions of years from now, the Sun will expand and destroy Earth. Long before that, we might face asteroid impacts, climate change, or other challenges. Learning how to live in space gives humans options for survival. Fifth, and maybe most importantly, exploring space is part of human nature. Humans have always been explorers. We explored every continent on Earth. We climbed the highest mountains and dove to the deepest oceans. Now we're exploring space because that's what humans do. We're curious, and we want to know what's out there. Chapter 35. The Night Sky Through the Seasons. The night sky changes throughout the year as Earth orbits the Sun. Let me tell you about what you can see in different seasons. If you live in the Northern Hemisphere, it's opposite in the Southern Hemisphere. In winter, December, January, February, the night sky is spectacular. The constellation Orion the Hunter dominates the southern sky. You can easily see Orion's belt, 3 bright stars in a row. Below the belt is the Orion Nebula, a cloud where new stars are being born. Winter also brings bright stars like Sirius, the brightest star in the night sky, Betelgeuse, and Rigel. In spring, March, April, May, you can see the Big Dipper high in the northern sky. The Big Dipper is part of a constellation called Ursa Major, the Great Bear. If you follow the arc of the Big Dipper's handle, you'll reach the bright star Arcturus. Spring is also a good time to look for galaxies. The Virgo cluster of galaxies is visible through telescopes. In summer, June, July, August, the Milky Way is best visible. Look toward the southern sky after dark, and you'll see a band of light stretching from horizon to horizon. That's our view of our own galaxy from the inside. Summer also brings the summer triangle. 3 bright stars, Vega, Deneb, and Altair, that form a big triangle in the sky. In fall, September, October, November, you can see the Great Square of Pegasus. Fall is also when the Andromeda Galaxy is best visible. The Andromeda Galaxy is the most distant thing you can see with just your eyes. It's 2.5 million light years away. Fall is often when good meteor showers happen too. Chapter 36: Meteor Showers and Shooting Stars. Since we're talking about things in the night sky, let me tell you about meteor showers which are related to comets. Remember how comets shed dust and gas as they orbit the sun? Well, that dust doesn't just disappear. It stays in orbit along the comet's path. Over thousands of years, the dust gets spread out all along the orbit, creating a stream of tiny particles. When Earth's orbit crosses one of these dust streams, the particles hit Earth's atmosphere. They're moving so fast, up to 160,000 miles per hour, that they burn up from friction with the air. We see them as streaks of light called meteors or shooting stars. Several times a year, Earth passes through major dust streams, creating meteor showers. During a meteor shower, you might see dozens of meteors per hour. The meteors seem to come from one part of the sky, and we name the shower after the constellation that point is in. The Perseid meteor shower happens every August. It's created by dust from Comet Swift-Tuttle. The Leonid meteor shower in November comes from Comet Tempel-Tuttle. The Geminid shower in December is unusual because it comes from an asteroid, not a comet. Watching a meteor shower is fun and easy. You don't need any equipment. Just find a dark spot, lie back, and look up. The best viewing is usually after midnight and before dawn. Bring a sleeping bag or blanket to stay warm, and give your eyes time to adjust to the dark. Every meteor you see is a tiny piece of a comet burning up in the atmosphere. Maybe a grain of sand or a small pebble. These particles might have been traveling through space for thousands of years before they hit Earth and created that brief flash of light. Chapter 37: The Moon's Journey. Let me also tell you about Earth's closest neighbor in space, the Moon. The Moon orbits Earth at an average distance of about 240,000 miles. That's close enough that astronauts were able to travel there in the 1960s and 1970s. 12 humans have walked on the Moon. The Moon takes about 27.3 days to orbit Earth once. But because Earth is also moving around the Sun, it takes about 29.5 days for the Moon to go through all its phases, from new moon to full moon, and back to new moon again. The phases happen because we see different amounts of the Moon's sunlit side. During a new moon, the side facing us is dark. During a full moon, the side facing us is completely lit by the sun. In between, we see crescents, quarters, and gibbers. More than half, but less than full, phases. The Moon doesn't produce its own light. It only reflects sunlight. But moonlight is actually useful for astronomers. When the Moon is full and bright, it washes out faint objects in the sky, making it harder to see dim comets or distant galaxies. But when the Moon is new, dark, that's the best time for deep sky viewing. The Moon affects Earth in important ways. Its gravity creates ocean tides, the daily rising and falling of sea level. The Moon also helps stabilize Earth's tilt, which keeps our seasons regular and our climate relatively stable. Without the Moon, Earth would be a very different place. So next time you see the Moon, remember, it's been Earth's companion for over 4 billion years, and it helps make our planet a good home for life. Chapter 38: Dreams of the Future. As we near the end of our story, let's think about what the future might hold for space exploration and comet studies. In the coming years, we'll discover many more comets. Our telescopes keep getting better, and we're finding smaller, and more distant objects all the time. Some of these comets might be as spectacular as SWAN, giving us amazing shows in the night sky. We're also planning more missions to visit comets up close. Future spacecraft might not just fly by or orbit comets, they might land on them, drill into them, and bring samples back to Earth. Imagine having actual comet ice in a laboratory where scientists could study it closely. Some people even think we might mine comets someday. Comets contain water ice, which could be melted and used by astronauts living on the Moon or Mars. Comets also contain carbon and other elements that could be useful for building things in space. Far in the future, humans might travel beyond our solar system to visit other stars. The journey would take thousands of years with our current technology, but maybe someday we'll figure out how to go faster. And along the way, these future explorers would pass countless comets drifting in the space between stars. But even if we never travel to the stars ourselves, we can still explore the universe through our telescopes and spacecraft. Every discovery helps us understand our place in the cosmos. Every comet that visits tells us something about where we came from and where we're going. Chapter 39. A Bedtime Thought. As you lie in bed tonight, think about this. Right now, at this very moment, there are billions of comets sleeping in the dark, cold reaches of the Oort cloud. Some of them will sleep forever, undisturbed, but others will someday wake up and begin their long fall toward the sun. One of those comets might arrive during your lifetime. Maybe you'll be the one who discovers it. Maybe you'll point your telescope at the sky or scroll through spacecraft images and notice a fuzzy spot that wasn't there before. Maybe you'll be the one to alert the world. A new comet is coming. Or maybe you'll simply be one of millions of people who go outside on a clear night to see a comet with your own eyes. You'll stand under the stars, looking up at a visitor from the ancient past, and you'll feel that sense of wonder that humans have felt for thousands of years. The universe is huge and mysterious, full of wonders we haven't discovered yet. Comets are just one small part of that universe, but they remind us that we live in a dynamic, ever-changing cosmos where amazing things are always happening. Space isn't just out there, it's all around us. Earth is in space, flying through the void at incredible speed. You are in space right now, riding on spaceship Earth as it orbits the sun. Chapter 40. Sweet Dreams Under the Stars. And so, young stargazer, our story comes to an end. Comet SWAN came and went, putting on its spectacular show, and then fading back into the darkness. It taught us about the early solar system, about cometary behavior, and about the beauty of the cosmos. But the story of human curiosity never ends. Tomorrow night, someone somewhere will discover something new in the sky. Next year, another comet might surprise us with its brightness. 10 years from now, a spacecraft might send back pictures that change how we understand the universe. And maybe, just maybe, you'll be part of that story. Maybe you'll become an astronomer who studies comets. Maybe you'll be an engineer who builds better telescopes. Maybe you'll be a teacher who inspires the next generation to look up and wonder. Or maybe you'll simply be someone who remembers to look up at the night sky once in a while, who takes a moment to appreciate the vast universe we live in, and who feels grateful to be alive in this amazing cosmos. As you drift off to sleep tonight, imagine Comet SWAN still out there, now far from the sun, slowly freezing solid again. It's beginning its long, lonely journey back to the Oort cloud, where it will sleep for another 22,500 years. But the universe doesn't sleep. Stars are being born in vast nebulae. Black holes are swallowing matter in distant galaxies. Planets are orbiting alien suns. And somewhere out there in the darkness, another comet is beginning its long fall toward the sun, perhaps to visit Earth in your children's time or your grandchildren's time. The universe is waiting for you to explore it. All you have to do is look up. Sweet dreams, little astronomer. May your dreams be filled with stars, comets, and the infinite wonders of space.